But I think it's worth to unpack what the hexadecimal to decimal is actually doing. And then we'll come back to this line, and this will make much more sense. But just one last thing before we dive into that. Notice that the colors class has this static method decorator on the hex to RGB method, indicating that this method does not rely on any instance-specific data like self or class. So in this case, this method behaves pretty much like a regular function, but is defined within the class function, mostly for organizational purposes. So we could actually call this method colors.hex to RGB. You can see colors.hex to RGB, and then provide the input to this function, which is a hexadecimal. And then we would expect as output the RGB color. So we could run this, and we will obtain, notice that this is BGR and this is RGB, because the conversion is being handled here, and we're only calling this method. But you could see that we could call it separately within this class. So I just wanted to mention that as a peculiarity. But let's focus on hexadecimal to RGB conversion. So the first thing that we need to be aware of is that there is a mapping between hexadecimal and decimal. And we can see it in this conversion table from MathMonks, where you can see that the hexadecimal values have a corresponding decimal values that they map to. So this mapping is very important. So what I did is I created a dictionary where it maps the hexadecimal to the decimal, as you can see here. And then this function converts your hexadecimal to a decimal. So let's go ahead and run this. And then here, let me show you. If I put, for example, F, we would expect 15 coming out of this function. So let's run this. And in a similar fashion, the other values will convert as well. So now that we have this function, we want to know the math of how we go from this hexadecimal, which is the one that is here for our car. How do we go from that to the value that we obtain above? And in order to do that, I created this hex to RGB. Notice that this function will call this function within. You can see here. And we're going to do the step-by-step math for this one example. But this function will work for any other hexadecimal to RGB. So in our case, if we focus on hash sign FF701F, if we plot this value here, you can see that we obtain this orange color and the corresponding RGB values, 255, 112, and 31. And in a similar fashion, we could also input it here, where we get the same values. So how the math works is the following. We start with the hash sign, and we have 7 digits in total, including the hash sign. So for the red channel, we first look at index 1, basically the first F, and we convert that from hexadecimal to decimal with the function that we define above, with this function. So F will be 15, and then we multiply that value, the decimal value of F, with 16, meaning 15 times 16. And then for index 2, that hexadecimal, we convert into decimal, and this will be 15. So that F will become 15, and that gets added to the previous operation. So this is F. When converted, this is 15 times 16, 15 times 16, plus this is F. When converted, this is 15 plus 15, and that gives us 255. And then similarly, for example, for the green channel, we get 70 for index 3 and 4, and then 7 corresponds to a 7 in decimal as well, times 16. So that 7 gets converted to a 7. This 7 gets converted to a 7. This 7 gets converted to a 7. And then the 0 gets converted to a 0. So 7 times 16 plus 0 is 112. And then similarly for 1F will be 1 times 16 plus F. We already know that F maps to 15, and that would be 31. So when we run this, the RGB, we would expect to be 255, 112, and 31. And then here for BGR, we're just inverting index 0 and 2. And you can see that we obtain the values that we expected. Now, this is the way to do it step by step. So you can actually see the math that is happening under the surface. But in reality, as well as in our colors class above, as we'll see in just a moment, they actually calculate the values in a more direct way. So let me comment this and uncomment. So if we want to convert hexadecimal to decimal, we could just provide the hexadecimal value here, and the built-in int function, if you provide the base of 16, you'll convert that pair of strings, in this case FF, you can see here, FF, base of 16, will be converted to 255 directly. So these operations right here are performed by the int method when you provide the base. So in this case, notice that for the red, we provide FF, or index 1 and 2, and then index 3 and 4, and 5 and 6. And that way, we calculate it directly instead of performing the operations. As you can see here in the Python built-in functions, where if you provide the string and then the base, which by default is base 10, basically you don't want any conversions, but if you provide base 16 or base 2 or other base, then by providing it here, it will calculate it for you. And now that we have unpacked this better, notice that 133557, base 16. So now what this line is essentially doing is the same that we're doing at the bottom, where we have the tuple and we have a for loop for I equals 0, 2, and 4. So notice that this is I plus 1. Well, the first one will be 0 plus 1 will be 1. And then I will be 0 plus 1 plus 2, that will be 3. So the hexadecimal first and second index converted to a base 16 with the int function. And then the next one, well, 2 plus 1 will be 3, and 2 plus 3 will be 5. And then the same with the third one, with I equals 4, 4 plus 1, and 4 plus 3 will give you the same result as we see here. And then that gets returned to palette, and palette was called from here. So C is that value, and then given that BGR was set to true, then we invert index 2 and index 0, and that would be the output to this function. So 31, 112, and 255 is the output here. Here it was RGB, but BGR is this one. And we obtain the same results as well here.